The next presentation I'm really interested in as well. It's from Phillip Blondin from Boardwalk Pipeline. Phil's been with Boardwalk for 14 years now. He's part of the IT GIS team supporting creating GIS for their in-house business. And Boardwalk's been really in the middle of executing a multi-year approach to upgrading their system. And really what their goal was to try to reach out to a much wider audience within their organization. So Phil's going to tell us a little bit about the history of those efforts, what some of the experiences are, and then show us some real world examples of the web maps and dashboards and interfaces that he's built for his organization, and moving that core system of record information out and make it available to a much wider audience within Boardwalk Pipeline. So with that, I'd like to bring Phil in.
Thank you, Jeff. Boardwalk would like to showcase some of the GIS efforts that we've done in recent years today. And we had a plan. So our plan was to position Boardwalk as a leader in GIS technology. But what does that mean? Does it mean we just want to have that title? But no, we had a reason. We wanted to increase collaboration between the departments and situational awareness and create an environment of geographic driven decision making. And why do we want to do that though? So we feel the result would be an advantage by the sharing of this visual information and seeing insights into data, and promoting the safety of the pipeline assets, and therefore increasing public safety around the assets. Let's look at a timeline for Boardwalk. Starting in or previous to 2012. We had multiple companies with different, software and infrastructure, different databases, different PODs databases, different processes. We have, different departments, had different management structure. So, if you think about that for a minute, it's could be a little inefficient. But starting in 2012, we moved everything to, the current version of Esri software, to a common platform, single PODs database, company agnostic tool sets for ACA and class, pipeline maintenance and reports. Other applications such as alignment sheets. We also had a common entry point through the Amazon cloud and Citrix desktops. We had no more local installs. This was actually a performance advantage for many users because we could open up one or more machines. We could run a heavy process on one, and a user could edit data on another machine. In 2014 was a pretty big milestone for Boardwalk. That we had no web-based applications before that, but we did implement a Google-based solution to make GIS data accessible to all company personnel through a web browser or on a mobile phone. This really was the start of a lot of GIS collaboration and awareness at Boardwalk, because previous to that, it would have been PDF maps or paper maps or KML files. So this was really the start of seeing GIS data. Being able to pull that up on your phone, starting to see it in a software application. It starts users to think about things. It starts the light bulbs turning on. There were some limitations to this though. So in 2019, we implemented our GIS portal. At this point, what did we want to do with that? We wanted to create a collaborative GIS environment. We want users to be able to share GIS data and publish this data, consume data from other sources into one single application where they could make their own maps, look up data. They could share other GIS information with other users. So we created one company-wide mapping application in 2019. In 2020, Boardwalk had increased GIS activity around TVC applications and corrosion and ILI. This was also the proliferation of dashboards. That once the first one was created, users could see the advantage that those had, and they started coming up with their own ideas and wanted to create many more of those to showcase data for their managers or just high level statistical type information. In 2021. We started with data synergies. We had increased collaboration. We also were investigating data integrations with other systems, and we're also working on the development of a portal-based as-built project tracking system. In the next few slides, we'll focus on the 2019 to 2021 time frame in more detail. But in 2019, we implemented a portal in an HA environment in AWS. So it handles the failover for reduced time, and we've nearly had 100% uptime since this implementation. One of the first items that we created in the 2019 implementation was a main company web mapping application. This application, allowed users to search data through just a standard text search or map click search to view any of the record details, hyperlink documents. They could, create maps, load KMLs, look at imagery, street view, pictometry. They had other just standard tools such as, drawing graphics on the screen or instances. So some of the standard widgets, out of the box widgets, the add data, drawing graphic tools and measure tools. We had, adding base maps. We also had a custom KML loader. And we also had a few other custom widgets such as, pictometry, integration with pictometry and street view, hexagon imagery. Created a profile widget on there for reviewing hydro tests. Previous to that, we went to Google Earth. We'd go outside of this and go to Google Earth, and a person would try to overlay something in there. So we had two different applications. So then we just implemented everything that users needed to do into one application. And from here, the users can also search for GIS data. They have different methods of that. They can just do a straight text search, or they can start limiting those searches to a specific layer or map extent. They can draw a user-defined polygon on the screen and search for any type of GIS data. When a user does a search, it will return back the search results grouped by the layer. If a user needs to click on a map to return data, that is also supported. So with one single click on the map, up to 70 data layers are returned, just whatever is found underneath that clicked point. All the data is all grouped by its type, so a user they know that HCA data is under HCA, or centerline data is under the centerline header. From there, if a user needs to see more detailed information, they would just click on each one of the data headers, and it would open up some of the features that are under it, and then from there the features would have the record details. So users can then see how many features were under each one of the layers, open up the record details. They can zoom to those, flash the records if needed. We also have supporting of hyperlinked documents such as valve maps, as-builts, MTRs, POs. All those are linked in with the GIS data from the document management system, and they will pull up as PDF documents through this software. In 2020, we also had the focus on dashboards. The first one was the COVID-19 dashboard. From here, we created a script that would download the Johns Hopkins data and do some spatial operations to update the numbers within a distance of Boardwalk facilities. This was really the first one that was created. And from there, that's sort of when the light bulb started turning on to see use cases for GIS as well, as far as dashboards go. So now that we knew that we had map services running, feature services running, and we had an avenue to create these, other users started to think about it as well. So not everything was coming out of IT. Then we had a risk dashboard. We did not have that before. So now we could see risk by area or company. We could have that. What is the highest risk and what are the drivers? So these dashboards then could now consume data and analyze data and present it to the user. We created a PHMSA mega rule dashboard. This would show, MAOP reconfirmation areas, HCAs, assessments outside of HCAs, or assessments outside of HCA areas. It'll show, counts and numbers, schedules, where they're located at, what area they're in, what pipeline they're on. Previous to this, it would have been spreadsheets. We also did an integration with another system, SCADA system. We started pulling that information in and to show, SCADA systems that are down. A lot of this was born from the event of all the hurricanes that we were having in 2020. Previous to this, we would just export out the SCADA system and see what was down, and we would give reports to management. once we started thinking about it, though, and we knew, well, this is just data, we set up some geoprocessing services that would consume this data in. On top of that, though, it also does some geoprocessing services with the hurricane layer, and it'll select sites that are within a potential impact of those. What did that lead to? It helped with disaster preparedness. So before that, hurricanes would come in and they would destroy things. So now at least we have some idea of what could be impacted, and it's on the fly. So instead of having a spreadsheet, XY coordinates, try to make a layer from it, get with the GIS analyst, hey, can you give me a PDF map back? Give me some list. Now you have something that's running constantly, and it's in real time, telling you what a disaster could be. So now we have advanced information, and this is what we were talking about before with situational awareness. This is a great example of that. Then we moved into the CIS area. Previous to this application that we had is spreadsheets again. So users would have spreadsheets from the vendors. They would go through there and categorize it based on the criteria, manage everything through a spreadsheet, pass spreadsheets around in emails. Now we have an application that can consume a CIS spreadsheet. It'll consume that and load it to a database, analyze the data on the fly, present it back to the user quickly. Previous to that, the user had to do everything manually. So now we have huge process improvements. A user can upload a survey from a standard CIS spreadsheet from a vendor. Once they have it loaded, they can just pick that survey, click Analyze. What it will do is group the CIS data by category. In this case here, giving one example like the negative 850 criteria. Once it does that, it presents it back to the user and says, hey, these are the areas that we have found. These are the areas of interest. These are the amount of anomalies that we had. What do you want to do about it? So from there, the user can, look at the CIS chart. The CIS chart is integrated with the map. So as you move up and down the chart, there's a red X on the pipeline that will move up and down and kind of pinpoint where these locations are at. From there, the user can pick a potential remediation for that. So let's say we had something with a negative 850, some criteria in there. Maybe they want to increase the CP or install a ground bed. So they can pick these potential remediations, then save those, just puts it as a schedule at that point. So now we have a list of recorded potential remediations. We have a corrective action, a compliance date who it's assigned to. You can think of this as like a BAP for CIS. So basically you're picking an assessment. Then you're going to go do that assessment. And did that assessment, did it correct it? So how do you do that? How do you know that? So this application supports, follow-up surveys. So you just reload the confirmatory CIS. So you know that if you did increase CP or install a ground bed, you're going to do a follow-up confirmatory CIS survey. And the user would just load that, and it's attached to that record. It analyzes the data again and returns it back. There's no anomalies found. So we know that this remediation activity corrected the problem and can be then closed out. Again, one of the beauties though of these systems with GIS data, having things in enterprise geodatabases, map services running, feature services running, again, we can create dashboards. So instead of a manager going to that application, trying to figure it out, trying to export something out, or filter data, they just go straight to the dashboard, high level right there on the spot. I see everything that's going on. This is really a huge deal for a GIS community, especially when you go from things like spreadsheets and paper maps that everything's right there at your fingertips. It's a massive process improvement over previous activities. While we were working on the CIS data, we also moved into the anomaly dig area. So we also got, you get vendor spreadsheets back of anomaly digs. When you run an ILI run, they say, okay, here's some investigations that need to happen. Previous to this application, a user would input that into an access database one at a time. So we decided to take that, move it into an enterprise geodatabase. It follows some of the same principles, but with process improvements. So at this point, a user can type in an XY coordinate to create an investigation from that. The application will, select all the pipelines around that coordinate, return that to the user and say which one is this anomaly supposed to be on. And when they pick that, and create the investigation, snap it to the pipeline and pull all corresponding map information underneath that point. That's a pretty big improvement over a user clicking on the map for each item, then going and typing it into a form. Now you have an automatic data retrieval. You also have increased accuracy from this because a user could input the wrong value, and now we're pulling what is exactly on the map. So what is another derivative work of this? Well, if you think about the PHMSA 7100 Part F, there's a lot of metrics there around anomaly digs. Like in the calendar year of 2020 or 2021, how many anomalies were remediated in an HCA? Well, we have all that information right there because it pulled it. So now you actually could create a dashboard that had those metrics on it. A user could just have a date filter on it and say for 2020, what are the metrics? And it would pull it up right in front of them. Previous to that, a user would have to get a download of the data, filter in Excel, they would type numbers in, add everything up. So now you're starting to see these huge process improvements. So these are the advantages that I'm talking about with the GIS system. Once that's input, we now have a recording of investigations. And then again, the dashboard goes on the schedule. Managers can come to the dashboard, see a high level schedule, see what's going on, what types of digs do we have, when are they going to happen, where are they at, who are they assigned to. Previous to that, what would they have? Hey, send me a spreadsheet and an email. Next week, send me another spreadsheet. Now they just go here. We also implemented a TBC application. This application is another portal-based application that reads data directly from pods, so it has a direct connection through geoprocessing services. It can read the pipe segment data, test pressure data, and grandfather pressure data on the fly. It can also, on the fly, dynamically segment the data as well and present the view to the user. Users can attach documents, so they can link those documents from the document management system. So all they have to do is go there, they see it, there's a hyperlink address, they just attach it, that's it. So anytime they pull these records up, if they click on any of the records in here and go to the Documents tab, all the documents are right there and recorded in front of them. All they do is click on it, it'll open them right up. There's a two-step validation process. So when a user selects, a pipe segment record or test pressure record or grandfather record, it pulls the pod's data into the view, and then they type in the data that that is appropriate. If it's the same data, then they just click a checkbox at the top, and it will fill everything out for them. And then they save the record. Once that happens, the next user can come in to validate the record. Once both sets of users have validated the record, it is then at that point TBC'd and ready to send the data to pods. It also keeps a history of user comments. So all the comments the users input are attached to that single record. Once complete and the data needs to move to pods, a user just clicks the send to pods button. It brings up a list of versions. You pick the version, it moves straight into pods. This is a pretty big improvement previously because we had SQL scripts that we would get from another application, and we'd have to take those scripts and apply those to versions. Someone would have to validate that. There would always be some kind of change. We'd have to go and revert back, change the SQL script, bring it back in. We don't have to do that now. Everything is validated through a one-stop shop. You see it, it's been validated, you click a button and it moves it in. So what's going to happen in Boardwalk in 2021? Well, we're starting to do some Maximo integrations. We have an effort between Boardwalk and ActiveG where we're pushing Maximo work orders into Portal. We've actually done that and implemented it. We're also working on an as-built, project tracking portal application. This is a collaboration between Boardwalk and GeoJob. So we're integrating an Oracle accounting system. We're also integrating with Pega, and it tracks compliance impacting type related projects such as reroutes and replacements and pressure tests. Things where we want to know a spatial location. Why do you want to know a spatial location? Well, because we want to support the opportunistic dig rule from the PHMSA mega rule. We'll also end up with another dashboard of metrics, that show these are the projects that are in process what their progress is. If anything is delinquent or it has some kind of error, like missing a document or a document's incorrect, all of that will be at high level, metric information for managers. While this system is, recording and managing the information, it also allows for, automatic notifications to project managers. So this is a pretty big system that we're implementing as well this year. Just another improvement at Boardwalk. So as a recap, if you think about where we started at, and where we're at now, it's just a massive change. It went from desktop GIS, spreadsheets, PDF maps, KMLs, and then the timeline starts. You start having collaboration. You start seeing GIS awareness. You start bringing in a bigger group of people, and they start talking about it. They start thinking about it, seeing things. There's a lot of visualization. They start saying, hey, they reach out to you. Hey, can we do something like this? I have an idea about something that would really improve our system. So it's really the main thing is, what are you trying to do with this? So at Boardwalk, we're trying to improve. We're trying to move forward. We're trying to increase public safety. We're trying to make, things that are unknown into a known as far as data goes. These systems are allowing us to be, better and faster, at what we do. It's bringing a lot of awareness to GIS, a lot of this geographic driven, decision making. So if you, the last thing is, if you think about that, every single thing in the world, has a spatial location. And, everything, and sometimes hard for me to comprehend why everything's not in a GIS system, because every single thing is 3D. When you move it in there, you can really visualize things. You can really have insights in the data. You can really make good decisions on what you're trying to do. Thank you.